Imagine a hot day, the sun burns your roof, your room feels like an oven, you turn on your air conditioner, the power bill climbs, the noise fills the room. Now imagine a small bag of white powder, it costs about $2, no wires, no noise, no machine, yet it can make things cold, very cold. Sounds like magic, right? But it is not magic. It is science, old science that people have known for many years. This powder can drop temperature fast. Some people say it can cool drinks, food, and even small spaces. But here is the strange part. In many places, it is restricted. Some states even banned it. Why would a cheap cooling trick be banned? What is this powder really doing? The story behind it is surprising. The powder is called ammonium nitrate. It looks simple, just tiny white crystals. Farmers use it as fertilizer, chemists use it in labs, but it has a strange power. When mixed with water, it pulls heat away very fast. This happens because of a process called endothermic reaction. That means the powder absorbs heat from its surroundings. The heat disappears into the chemical reaction. When that happens, the nearby area becomes cold. You may have seen this before without knowing it, many instant. Cold packs use this same idea. When you squeeze the pack, the powder mixes with water. Seconds later, the pack turns ice cold. People soon realized something interesting: if the reaction can cool a pack, could it cool other things too? Years ago, survival experts began testing it. They mixed ammonium nitrate with water inside metal containers. The temperature dropped fast, sometimes below freezing. It worked like a tiny cooling engine, no electricity needed. Some people started calling it the $2 air conditioner. The idea spread online. Videos showed small coolers and DIY cold boxes using the powder. In theory, it could cool drinks, medicine, or food during heat waves. But here is the truth: it cannot replace a full home air conditioner. Not really. The cooling effect does not last very long, and the chemical is used up after one reaction. Still, the idea fascinated people, a cheap cooling trick that worked anywhere. But that curiosity soon caused problems. The problem was not the cooling, the problem was the chemical itself. Ammonium nitrate has another side, a dangerous side under certain conditions. It can become explosive, very explosive. It has been used in large industrial accidents. It has also been misused in bombs. Because of this, many governments began watching it closely. Stores stopped selling large amounts to the public. Some states added strict rules, others banned certain retail sales completely. Not because it cools things, but because it can be turned into something deadly if handled the wrong way. So the famous $2 cooling powder became controversial, a useful chemical, but also a risky one, and that risk changed how people could buy it. Even fertilizer versions became controlled in some places. Farmers still use it, but the supply is tracked. Buyers often need licenses or records. Why so strict? Because history showed the danger. Several large explosions happened when ammonium nitrate was stored poorly. Warehouses caught fire. Massive blasts followed. Entire buildings were destroyed. Those disasters forced governments to rethink safety rules. If huge amounts can explode by accident, smaller amounts could also be misused. So, regulations grew stronger. This is why you may hear claims like banned in many states. The truth is a bit more complex. In most places, it is not completely illegal, but selling it freely to everyone is often restricted. Safety laws changed the story of this strange cooling powder. Still, the science behind the cooling trick remains real. When ammonium nitrate dissolves in water, its ions separate. That process needs energy. Where does that energy come from? Heat. The chemical pulls heat from nearby materials. Your hand, the container, the air around it. As heat disappears, temperature drops. This is why instant cold packs feel so icy. The reaction steals warmth from your skin, but once the reaction finishes, the cooling stops, the powder is used up. That means you cannot run it forever. Like a real air conditioner, it works more like a one-time cooling burst, powerful but temporary. Useful in medical kits, sports injuries, and emergency cooling. So could it cool a whole room? Not really. The chemistry would need huge amounts of powder that would become expensive and risky very quickly. Air conditioners work differently. They move heat from inside your house to the outside using compressors and refrigerants. The process repeats again and again. That is why they can cool a room for hours. Ammonium nitrate cannot do that cycle. Once mixed with water, the reaction ends, no more cooling. But the idea still teaches something interesting. Chemistry can control temperature. Some reactions create heat, others remove it. Humans have been studying these tricks for hundreds of years. In fact, scientists are now exploring safer cooling chemicals, researchers study. Materials that absorb heat without danger. Some can cool buildings, food storage, or medical supplies. One exciting field is called phase change materials. These substances store cold energy and release it slowly. They may help future cooling systems use less electricity. As the planet gets warmer, cooling technology becomes more important. Air conditioning already uses a huge amount of global power. Finding cheaper and safer cooling methods could help millions of people stay comfortable. The strange story of this powder reminds us how powerful chemistry can be. Even simple crystals can control heat in surprising ways. But there is also an important lesson here. Not every viral life hack is as simple as it seems. Online videos often show dramatic experiments. They make it look easy and harmless, yet chemicals deserve respect. Some are safe in small controlled uses, but dangerous in larger amounts. That is why scientists train for years to handle them correctly. Safety rules exist for a reason. They protect people from accidents that could cause serious harm. So while the idea of a $2 air conditioner sounds exciting, it is more of a science curiosity than a practical solution. The real story is not about a secret cooling trick, it is about how powerful chemistry can be. And that is what makes this story fascinating, a simple white powder, cheap, common, and easy to overlook, yet it can freeze a cold pack in seconds, feed crops as fertilizer, or cause disasters if misused. Few substances show both sides of science so clearly, helpful and dangerous at the same time. That is why rules exist around it today, not to hide a miracle air conditioner, but to prevent accidents and misuse. Still, the cooling reaction remains a beautiful example of chemistry in action. Heat moving, energy shifting, nature following precise laws. Sometimes the most surprising science hides in everyday materials, and once you understand the story behind them, you start seeing the world very differently.